Alright, I'm updating the backboard really quickly. Homework number 1424 is due tomorrow because we're only taking one day on them. That's all we need. Complex numbers. Question. Why should the square root of -1 be given his own little representation? What's wrong with him? Why isn't he just 1? What?
He's his own person.
He's his own guy.
Yeah.
He's unique. Get real. Why is it a problem though? Why is it unique? Why is it imaginary? Why is it different? Why can't we find the square root of -1? Because they're imaginary. True. But why is nothing square? No.
Like negative squared is always
A negative times a negative is, and I heard a lot of you saying this, good, so negative times a negative is, and a positive times a positive is. The only way to get a negative is if the two have different signs. Well, if they have different signs, are they really being squared?
No.
No, so then we can't undo a negative number, at least not in a real way. However, if you research, and I might be able to show you something tomorrow as to a practical application of imaginary numbers or why we talk about them. But with imaginary numbers, square root of -1, yes. If you were like in little algebra 1, we'd say it's not real. It doesn't exist. That's good. But we got to go further than that, and we establish him to be I. Not me, I. Okay? Which is why you don't really see I being used very commonly as a variable in math. Same thing with E, same thing with pi. Oh, that's a Greek letter. But either way, has a very particular meaning. Now, standard form of a complex number, wait. Complex number? Who's a complex number? A complex number is a number that might have both a real component, no I, and an imaginary component. And that imaginary component can have a coefficient, that's not a big deal. Bless you. But a complex number says, hey, it has a real component and an imaginary number, and an imaginary component. We can technically make even just real numbers, we can put them in complex form. And if we just have a alone, we can write it as a complex number. It would just be a plus 0i. And if we have just an imaginary piece, we can write that as a full complex number as well, 0 plus bi. So anything can be written, any real number can be written as a complex number, ironically. So complex numbers are kind of like the broader category. And imaginaries can be written as complex as well. But those are special ones. A more particular or more representative example would be something like 2 plus 3i, or -1 minus 2i, etc., etc., etc. Okay. So let's talk about what we can do with imaginary numbers, just mathematically speaking. Not how it applies and its application, this, that, and the other. How it's used in other fields or genres, but just how do we deal with those complex numbers mathematically. Adding and subtracting, we do what we always do. We combine like terms. Adding and subtracting, we do what we always do. We just combine like terms. However, we still beware of the poor little seals. We are so prone to kill. However, with addition, is it really that big a deal? Not so much, because if we distribute a positive 1, does it change any of the inside? So we can, in essence, rewrite it just the way it is, and we're doing just fine. True? But then we combine like terms and say, okay, what are our real pieces? 7 plus 5. So therefore, the real component will be 12. What are my imaginary pieces? 3 minus 4i. So my imaginary component will be plus -i or minus I. Same thing. Plus -i or minus I. You guys go. Don't kill anything. Do the subtraction. Keep going. Don't kill anything. Please, please. If you're trying to mental math it, just make sure you don't miss anything. Did you get there? Because distributing a positive 1 keeps it the same, distributing a negative 1 flips each of the signs. 3 minus 5, negative 2, 3 plus 3i plus 4i, 4i plus 3i, 7i. Done. Adding and subtracting, not bad, right? Okay, good. Let's keep going then. Multiplying. This gets a little more exciting. For the one, poor puppy could die. But we're gonna all be careful. Right? We're gonna be careful. We're gonna see. You cannot just square both pieces. That is the error, the common error. So why am I saying distributing? Ooh, because what are we supposed to do? But even if you properly did it, you might still not know how to get to the best, the final answer. Now hold on, I skipped some lines. Don't just write 12 plus 16i. You foiled, and what did you get?
16
Uh-huh.
plus 8i plus 4i squared.
Good. Wait, what? That's not that. No, I know, but hold on, keep going. Good. That doesn't make sense. Unless we review who I squared really is.
Oh.
I squared would be the square root of negative 1, what? Squared. Right? Who is I? Square root of negative 1. But when you square a square root, oh my goodness, an imaginary squared is a real number?
So considering that the I is negative 1. It's stupid sharp.
16 minus 4 is... Even after multiplying, we still get another complex number. Chart. I'm going to show you something. I hope you don't just see it as a chart to memorize. Because to be honest, it's a chart you should be able to make, whether or not you have it memorized. And I think I have it on the next page. Let me check. Oh, I totally do. Before we get to something crazy, like what's I to the 35th or I to the 129th, because we don't want to make a chart that goes that high, right? No. So, we want to think instead of patterns that we can maybe apply to higher powers of I. So who is I again? Who is I? Square root of negative 1, right? Which can't break down. He's an imaginary number, he's I, he's done. I is I is I is I, we're done. Who's I squared though?
Negative 1. Oh, 1.
Or if we write it a little bit better. I think this made a little more sense. Square root of negative 1 squared, right? So who is I squared? And make him black, because this is who we can always make him be. I squared is negative 1. I cubed. Let me show you a different way of writing it. What if I made it I times I squared?
1.
Right? I times I squared is I times I cubed.
Negative.
Oh, it's negative one.
So negative one
Square root of
times-
Negative one.
It is negative square root of negative 1, but what's the best way of writing?
Negative square root of one, negative one. Oh.
Well, we're not going to write the square root of negative 1.
Oh,
It's
yeah,
like it's
yeah.
messy, right?
Yeah.
We don't really want to write him if we can write him instead. The best way of showing an imaginary number isn't the square root of a negative, it's I. So we're going to say negative 1 times I is negative I. Oh, okay, got it. How can I make, we substituted. Who's I? I. Who's I squared? Negative 1. Oh, negative 1 times I is negative I. Plug it in, plug it in. Now how do I do I to the 4th? Negative 1 times negative 1 is?
One.
So you can make the table yourself. You just have to think about what happens when you square I, and then what happens when you build I cubed or build I to the 4th from the lower powers of I. Now, question, what would I to the 5th be?
I to the 4th times I.
Now, you could do I to the 4th times I, that's true. But that means to do this one, I would need I to the 34th times I. Who wants to go to the 34th? No. So let's think of it in a different way. You do? Go to. What else can we do? I guess we could do I squared times I cubed. We could do I squared times I squared times I, right? If we're just going to use just the basic i's. Good question. What's going to happen with the, oh, who is that again? Negative 1 times negative 1 is positive 1. Positive 1 times I is negative 1 times negative 1, positive 1 times I. I to the 6 will be I squared times I squared times I squared.
Are they the same every?
How many negative 1s?
3.
Yes.
Oh, sorry.
Negative times a negative is a positive times a negative is a negative. Huh. Keep going. I to the 7th is I squared times I squared times I squared times I.
Negative I?
Negative 1 times I is,
Negative
uh-oh.
That
You're gonna get
pattern,
annoyed.
though.
Don't worry.
Your pattern.
Oh.
Is that a compliment? I think that's a compliment. Okay, so.
How'd it go?
I couldn't think of
Is
it.
that-
I to the 8th is positive 1 times positive 1 is 1. Oh my goodness. Every 4 it repeats. Because I is I to the 5th, I squared is I to the 6th, I cubed is I to the 7th, I 4th is I to the 8th. So, let me show you another way of doing it without having to write all of these I squares and I's. Sound good? Let's go to I to the 35th, but I don't really want to write I squared, I squared, I squared, I squared. Ugh. If it repeats every I to the 4th, let me just make it the whole page. If it repeats every I to the 4th, what we need to do is figure out how many 4s are in 35. Please. How many 4s are in 35? So, couldn't I make it I to the 4th to the 8 times and ask myself, well, there are 8 4s in there, but there are some more i's. And how many more i's? That's 32. There are 3 more. Why do I like I to the 4th quite a lot? It's just 1, and 1 times anything is itself. So I can take any powers, any multiples of I to the 4th, and I can say, oh, you're just 1. And so I can take that whole thing and say, oh, you're 1. And now all I have to deal with is I cubed. Who's I cubed? Oh, I have to remember that. You could make him I squared times I. You may do that one. Or you could just know, oh, he's negative I. So at the end of the day, this final answer would be So you guys, I want you to do I to the 129. Go. I to the 129. Where would he fall in the multiples of 4? How many 4s?
Oh, 32.
Yeah.
You can do division, right? 129, just divide by 4 real quick, and we have a 3, and that 12 goes away, and then we have a 2. How many i's are left? So what does that whole I to the 4th piece? Just 1. And 1 times I is... So Sean, could you memorize a table? I suppose. But I would make sure you had the first 4 down real well, yeah?
Yeah.
First 4 down, but maybe not the whole entire huge table that we could make all the way to the 129th power and beyond. Ew, no, let's not do that. That was multiplying! You guys see why I squared became -1 now? Wait, context. Why did we go over it? We had an I squared who shouldn't have and didn't remain. Because I squared was really -1. That's the best way to plug in, and then we can simplify. So if you get I to any power, you have to think of who is he. Because he's either a real 1, a real -1, or an imaginary I, or an imaginary negative I. Okay, moving on. Dividing. I need you guys to think with dividing. Imaginary numbers in the denominator do not belong. Or maybe I should say, should not remain. Imaginary numbers in the denominator do not belong. Or maybe I should say, should not remain. Is there anything else with denominators that shouldn't remain, even if a problem gets it down here? No, X's are allowed. I mean, we have like domain problems. But something from algebra 2.
Oh, the square radical.
We're not supposed to leave radicals in denominators, right? Similar idea with imaginary numbers. We're not supposed to leave imaginary numbers in denominators either. And how did we, it's probably been a while, but how did we get rid of square roots? 2 different ways. Depends on whether there's a plus or a minus. Long story short, we have to multiply by 1 creatively. What do I mean by that? By 1 creatively just means multiply by something over itself. And that something over itself just means times 1. Okay? Where do we multiply by 1 creatively? Let's see, we multiply by 1 creatively when we need common denominators. Anyway. What? That's crazy. That one's not spelled. What if I needed 1/2? Oh, this isn't quite so hot. Plus 1/3. Smells good, that's it. 1/2 plus 1/3. We need common denominators. Where do we multiply by 2 over 2 and 3 over 3? Why is that legal? When I multiply something by...
it's just 1.
That's just 1, and anything times 1 is itself, so it doesn't change the value. So I multiply by 1 creatively, like 2 over 2 or 3 over 3, to get it to be a form that I need. You guys are still...
So creative. Wow. Proud of this one.
Question. What do we do if we have a square root, like 5 over root x? Why do you multiply top and bottom by root x? Because we memorized it that way. Okay, so it cancels out. But why is it okay to multiply something by?
Because it was 1.
Anything times 1 is itself. right?
Yeah.
And then we get the whole 5 root x
Over
all over x. And it's like, yay, it's prettier, not really, but whatever. Okay, so, over here.
Had the double shot.
You had one or you need one?
I had it.
I'm not sure if it's working. Okay, so, yeah, so it's like, 5 over I. What if I multiply by like 2 over 2? Why I over I?
Because
So I'm not just multiplying by I? No.
no.
I have to multiply by I over I so that it's 1.
So then
Then I can get 5I over I squared. Oh, yay, look. Oh. Oh, some of you do that. Whoa.
Whoa.
Didn't help, right? Didn't help.
Yeah.
What do I do instead? I say, oh, I squared. He's somebody.
He's a 1.
Oh wow.
Fine.
Okay, yeah.
Dun, 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 dun.
Dun, dun.
Nice.
No. I was proud. So even a division can still be rewritten as a nice complex number, 0 minus 5i? Okay, alright. So we got this, right? Next example times I over I. Right?
No.
Why not? Hold on. Don't write it, but I'm going to go ahead and do it. We would need parentheses, yeah, to be all legal. For multiplying by 1. We would have 6i minus 7i squared all over 1i minus 2i squared. Those will become negative 1s times whatever. Isn't there still an I?
Yeah.
Oh, bingo's that theory. That didn't work. Who's the conjugate? You take what's down there and you say, I'm going to flip your sign, because when I flip your sign, it's called a difference of squares, which means, I'll do the top in a second, but the bottom, difference of squares. Does the outer inner really make a difference? It cancels. So I have first 1, outer plus 2i, inner minus 2i goes away, poof. Minus 4i, that's going to be a real number. Now on top it's a little worse, right? Sadly I have the 6 plus 12i minus 7i minus 14i squared. Ugh. That's okay, we're allowed to have messy stuff on top. We're just trying to get the imaginary out of the bottom. We end up with 6 plus 12 minus 7 is 5i minus 14 times negative 1. How did I, oh, I squared is negative 1. All over 1 minus 4 times negative 1. Oh, that's right, I squared is negative 1 again. Then I can break it down and say, negative 14 times negative 1 is a plus 14, right? 6 plus 14 is 20. Plus 5i. Negative 4 times a negative 1 is a plus 4, right? 1 plus 4 is 5. Better. The imaginary is gone. We can go further because
It's over 5. So
careful. What'd you just kill if you stop? You're not allowed to randomly cross out stuff just because it matches if there's adding and subtractions going on. What are we allowed to do? Okay, 2 things. We can either, and both, I heard both of them and they're both right. We can either take them away from the 5 and the 20. We're being legal, we're making sure it goes to both. Or we can factor out the 5 up top, and we can see it's 4 plus 5i. Now it's a nice multiplication, and we can say, ha-ha, that's just 1.
Wait, is 4 plus I?
So many mistakes can happen. So then final answer is
4 plus I.
that is really that? Don't you see why we'd rather work with him?
Amen.
So go. We've added, we've subtracted, we've multiplied, we've divided, and we've seen that all of them can come back real quick one more time to what form? Oops. This one. We just have to do different things to get them there, right? Going back to the division-y one. Are we almost there? You got it? We're close, yeah, go ahead. Okay. Okay. We have homework soon. Oh no, then we go a little bit crazy. Let me do one homework help real quick, okay? Homework help. Let's see if you got this.
No, I do.
Get them all three done. You're allowed to check in your groups. Get them all three done. Yes, please.
Yeah, that's what I'm thinking.
We'll just leave it as the final section. The final section examples. I think it's on, no, it might not be on the calendar yet. This chapter is definitely not as long as last chapter. We're in 2:4. It goes up to 2:7.
Honestly, I don't know. What it? Yeah, it's plus or minus 6i, isn't it? Because you're taking out the third.
I would say at the earliest next Thursday or Friday. At the earliest. The last few sections get a little hard and a little intense, like factoring, cubics, and quartics that aren't nice.
The one with the zeros are in So in Korean, N2, you have an N2 already?
Ooh, I should do my work. Kiddos, I need to give one more. One more. Just right here.
You put plus or minus 7 as a yes.
One more, just because I care. One more. Got a little intense, right?
Oh. Yeah. Bro. Yeah, but you can see the other side becomes a negative 49. So you have square root of negative 49. That's the imaginary number. No illusion.
I've put answers for the first two. Zeros, remember, set the whole thing equal to 0.
Oh, it's I squared is.
Any questions on 1 or 2? Remember when you put a square root in? Could have been a positive or a negative. When the square root is already there for you, you assume the sign is, well, if there's no sign, we assume it's positive, hence why only one answer. But when we put a square root in, plus or minus, right? Has anybody at least started the division one? What'd you multiply by? Nice, that's the conjugate. Probably distributed, right? Didn't kill anybody? I agree. Hopefully not. Oh, that would be cute. Like floating on the deck. You get stuck in trash that hasn't been properly recycled. Or oil spill. Basic club means it was purposeful. I don't think you guys make mistakes purposely, do you?
That's too many.
It's gonna be way too much fun. Did you guys reduce?
Yeah.
I'm gonna do this one a little bit differently with my reducing. Maybe you guys will see why. Because you can only pull a 5 out of the top, not a 10. So I did the other way of, hey, both get divided by 10. Then I can have a nice, I mean, it's a fraction, but I have a nice real part. And then I have a nice imaginary part. Right? A plus B, I, Nicole.
You can have them in one fraction.
You could have, but the problem is, by taking out the 5 and reducing, it'd be 5 over 10 is 1 over 2, right? You'd still have a 2 down here that we need. Yeah, but you still have a 2 on the left. It's the 5 over the 10 is only 1. And then the 2 could go to the other 2. I just need the 2 to go to both pieces eventually. Does that make sense? Because then I have a number plus a number I. So it's kind of just being a form, right? But yeah, you could have definitely started with pulling out the 5. Last one, he's the easiest. Okay.
If you have I minus 3, it's in parentheses over 2, is that not considered standard form?
No. Because technically I need one number plus one number times I, hence why we went one step more. So we divided each by 2. Karina, you have an idea?
Yeah,
How do
don't
you
you
start?
multiply, okay, so you multiply
Hold
1
on.
plus, 1 plus I over I by the top and bottom by 4 minus I. And then the other side you multiply the top and bottom by I.
Look at her getting common denominators. Not that much different than this one. You're like, no, it's way different. It's not that much different though, is it? Because we look at the denominators and say we need them to be the same. So he's going to get multiplied by him, top and bottom. One creatively, he's going to get multiplied by him, top and bottom. One thing you better watch out for though, you better put a parenthesis there too, right? So then, let's put the I in front. I don't know, it looks a little bit nicer if the easier one's in front. Up top we get FOILing, right? 4 plus 4I minus I squared. I know we can simplify, we'll come back to it. I FOILed, right? 3 times I. Once I have common denominators, what can I do? 1/3 plus 1/3 is 2/3. Why? Because you can put them together. They have the same denominator. Same thing here. I'm going to also combine a little bit because 4I minus 1I is 3I. Minus I squared is -1 minus 3I, right? 4I minus I is 3I. Minus I squared is -1. And then I have the minus 3I from over there. Huh. I times 4 minus I. Now what? 3I minus 3I. 4 minus a -1. Yay! Isn't he pretty? We're done. Then why am I putting it times? We could try to deal with them all at once, or we could deal with them piece by piece. How do we deal with it piece by piece? How about times I over I? Let's just deal with him first. And then we get 5I all over I squared, which is -1, times 4 minus I. We could do a few things with the -1. But one thing we could do is just distribute them in, and it'd be a positive I and a -4. What's the last thing we're going to do? No way. 5I squared plus 20I.
Wouldn't it be -4? Oh wait, no.
I distributed my -1 in, so -4. And I end up with I squared minus 16. Can I make it pretty? Yep, and I'm going to, but you guys can get out of here and I'll see you tomorrow.
I'm not entertaining you.
There are other ways of doing it. Oh, I got my high. There we go. There it is. Yeah.